Okay, so we have several problems from the last couple of days that we've been working on. So we're starting off on those pages 251 through 254, actually, in your packet. Any of those that you want me to go over? Okay, and that's usually about where the big questions hit, because those first 25 really are the ones. Just look up the thing you're trying to find, and the formula is right there. Yeah. Okay, which terms?
The pitch diameter and the pitch circle are the same thing. According to this.
Okay, the pitch circle
Yeah, 253. Pitch diameter and the pitch circle.
Okay. The pitch circle, Tom, if you look up here on the board, is that circle that goes around here. It's not the outside, it's not the inside, it's the working. So if it meshes with another gear, and the pitch circle of that other gear would be tangent to that circle, right? The pitch diameter is the diameter of that pitch circle. So yes, they are the same circle. It's just the pitch circle is the circle itself. The pitch diameter is the diameter of that circle. D would be the pitch diameter. The pitch circle has no number, but there is something called the circular pitch. And the circular pitch is, trying to get to it here, if I remember right, the circular pitch is just the circumference of that pitch circle. Well, what it is it's pi times the pitch diameter divided by the number of teeth. So it's the circumference of that pitch circle divided by your number of teeth. So your circular pitch is literally on the pitch circle, the arc distance from center of tooth to center of tooth. The pitch circle is the whole circle, but there really isn't a measurement for that. That isn't measured for any reason that we have that full circumference. Yeah, so it'd just be pi, it would be the circular pitch. Yeah. So let's start out with, does anybody have any questions on 1 through 25? Yeah. Well, like I said, on those, the 1 through 25, you look at what you're trying to find in the table there, and you just go to that in your formulas, and your glossary of formulas, and everything's just given there. What you are given in the problem is what you need to make those formulas work. So those are pretty. Yep, as long as you get to the right spot in the formula table. There is a lot of stuff going on with these gears. You are absolutely correct. And realistically, when you get into the field, you need to know the pitch circle, the pitch diameter, the pitch, number of teeth, clearance, and working depth really are the things that get used. Yeah. So let's take a peek here. Number 7. Since you guys have to do the odds, we're asked to find the pitch given the addendum is 0.0666. So if we look up the pitch, we do not have a formula that gives us the pitch from the addendum. So step 1 is to look up the pitch. And more specifically, the pitch is what we're trying to find. And we look up the pitch, none of our formulas for pitch have anything about the addendum in there. We've got number of teeth and diameter, and we've got circular pitch. Nothing about the addendum in there. So step 2 is look up the addendum. Yeah. In other words, we're going to look up what we're given. And so the addendum is what we're given. So yeah, we look up addendum and see if there's a formula for addendum that includes what we're trying to find, the pitch. In this case, there is. Now, if there wasn't, our third step would be to have to look up multiple formulas. And to look up multiple formulas, you take 2 steps. Step 1, look up what you're trying to find and see what do you need to calculate it. What are your options? And then the second part of that is look up what you are given to see if you can calculate one of those things that you need from what you're given. So in this case, the second option is going to work for us. We look up the addendum and we see that the addendum is A equals 1 over P. You got her. So what we can do there is we can put 0.0666 in for A equals 1 over P, the pitch. Now, this is a little bit of a weird formula to solve because pitch is on bottom, but we can simply do that. We're going to cross multiply and divide. 1 times 1 is 1 divided by 0.0666. So 15.015 is our pitch. The units on pitch, by the way, is technically per inch, or inch to the negative 1 power. Now, it's not one that we were assigned, but I am going to jump to number 30. Very similar to the one we just did. Mainly because I don't want to use up the ones that you're assigned, because I'm going to make you keep working on those today. Number 30, we are asked to find the number of teeth. We are given the outside diameter and the circular pitch, PC. Well, if we look up the number of teeth, there is no formula that uses the outside diameter or the circular pitch to find number of teeth. So let's look up outside diameter and circular pitch. Okay, we have that formula for outside diameter. DO equals N plus 2 over P. So the DO was what? 4.3750. N is what we're looking for. What was P? Oh, so we can't use that one. P is pitch. We've got circular pitch. So that formula ain't going to do it for us. But there was another formula there. DO equals circular pitch times n plus 2 over pi. So the DO was, what is it again? 3750 equals PC 3927. We're looking for n. So to solve this, there's a few steps to take. This is not an easy equation to solve by any means. Here's the way I would do it. I would multiply by the 3.1416 to get rid of that on bottom. So we've got 4.3750 divided by 3.1416. So we got 1.3926 equals 0.3927 times n plus 2. Normally, we would distribute this, but rather than doing that and having extra crap to work with, there's nothing else on this side of the equation other than that distribution, that multiplication. I'm just going to go ahead and divide by the 0.3927. So I've still got this in my calculator, divided by 0.3927. Got 3.5462 equals n plus 2, and then I subtract 2. So 1.5462, you got it, equals n. Now, there's something kind of fishy there, because what's n supposed to be? Number of teeth. How do we get 1.5 teeth? Broke one. Yeah. There's something in this here that just doesn't add up. So that may have been a bad problem to pick. It may not be. I divided here instead of multiplied, didn't I? That's what's the problem. The problem's right here. So let's do this again. 4.375 times 3.1416. That's the problem. That should have been 13, not 1.3. I'm just going to keep it in the calculator. I'm going to divide by the 0.3927. That looks better. I get 35, then I subtract the 2. So 33 teeth. So that's much better. So n is 33. Okay, now I'm going to jump down to that 35 through 43. In fact, I'm going to do number 34. Number 34, we're given that the number of teeth equals 72. We're given the pitch diameter, 6.0000. We're asked to find the addendum. If I look up the addendum, there isn't going to be a formula for addendum that requires number of teeth and the pitch diameter. Our formulas for addendum require the pitch or the circular pitch. So A equals 1 over P is a formula for that. Obviously, I don't have the pitch, but let's look up the pitch and see if we can find the pitch from the information that's given. P equals N over D, exactly. So I can find what I need from what I'm given. So I just have to go through 2 steps. So this is that third process we talked about. You look up what you're looking for, see what you need to find it. We need the pitch. And then you look up to see if you can get that from what you're given, and we can. So N is 72 over D of 6.0000 equals a pitch of 12. So our addendum then is 1 over 12, or 0.0833 inches. What do you think? Anybody looking for a sharp stick? Let's say number 38. Number 38, we are looking for the outside diameter. We have the pitch diameter of 1.0625, and we have the pitch of 16. So once again, we look up our outside diameter. We find that DO, actually a few things we can use for DO. I'm going to look at the n plus 2 over p. Yes, exactly. We're given p. We have that part right there, right here. But we don't have n. So let's look to see if we can find the number of teeth. N we see there is just p times d. So we're going to take 16 times 1.0625. Teeth at n is 17 teeth. Is that correct? So our outside diameter is 17 plus 2 over p, where p is still 16. 17 plus 2 is 19 over 16 is 1.1875. What do you think? That really is the trick, is finding the right formula. So what I want to do now is I am going to give you all of today to work in this packet some more after seeing some more examples. I'm going to go through now and just kind of do a variety of problems out of this packet, because this packet is Unit 2 for the semester, and we are done after today, which means tomorrow is Unit 2 test. This is like a hybrid quiz test. It's 40 points, kind of between a quiz and a test, because we only did spend 4 days on this stuff. 10 questions. Not so bad. Now, has anybody talked to you guys about what's happening on Thursday? This doesn't need to. Okay, so want to do some various examples out of this packet for you. So what we're going to do now is, let's say we have a 6-inch grinder. I'm just doing examples for various examples. They're not necessarily out of the packet. A 6-inch grinder running at 1480 RPM. Find the cutting speed. This is kind of a different example from what we've done before, because before, when we had rotating tools, it was either a lathe or a mill. Here we're looking at a grinder, but it follows the same process. Find our cutting speed. What is our formula? Pi times diameter is 1 rotation times RPM divided by 12. Why divided by 12? That changes from inches into feet. You got it. So I got 3.14 times 6 times 1480 over 12. Right. 23.6. That'll be feet per minute. That's moving. Yeah, that might be, of course, a grinder is way different. I don't have the charts for grinding speed. But that might be getting up there towards discoloration. Yeah. Okay, the second one I want to look at. Let's say we want to drill through a 4-inch depth. The drill is moving at 210 RPM and a feed rate of 0.02 of an inch per revolution. How long is this going to take? Now remember, cutting time is equal to the length of the cut divided by the speed of the drill. The speed of the drill is your feed rate times your RPM. So your length of cut is 4 inches. What's your feed rate? 0.02 times 210. Now remember, when you punch this in the calculator, it's 4 divided by, you have to put parentheses around the bottom. 0.02 times 210. Close that parentheses. Get 0.95 minutes. So just under a minute it'll take. Questions? Let's say we have a 5/8 inch diameter cutter running at 90 RPM. Find the cutting speed. I'm gonna give you guys a second to try this. So the cutting speed here is going to be pi times the 5/8 times 90 over 12. That doesn't sound too bad. That's what I'm getting, 14.719. 14.72 feet per minute, we'll call it. Now this next one is going to require not just a formula out of the packet, but a little bit of knowledge about how things fit together. Let's say we have 2 gears with outside diameters of 4 inches and 5.5 inches. The center to center distance is 4.58 inches. What is the pitch of the 2 gears? Obviously, both of them better have the same pitch because they're meshing together. Now, looking at this, it looks like we don't have the information we need, but we do. Outside diameters, of course, mean the circles overlap, right? A diameter of 4 means we have a radius of 2. A diameter of 5 means we have a radius of 5.5, I should say, 2.75. If our center to center distance is 4.58, what that allows us to find is the difference. 2 plus 2.75 is 4.75. We subtract from that 4.58. And what that gives us is 0.17 inches. That difference there, the overlap here, is called the working depth. From the working depth, can we find the pitch? What's the formula for working depth and pitch? Working depth equals 2.00 over P. So we know the working depth is 0.17. So it's just 2 over P. I'm going to get a proportion. 1 times 2 is 2 divided by 0.17. So I'm getting a pitch of 11.765 is my pitch. What do you think? We could. You won't get in trouble if you only go to 3. Any questions? That's kind of a sneaky little question, but it just requires you to know that the overlap of the outside diameters is the working depth. Once you've got the working depth, you're good to go. Okay, I'm going to give you guys the last 14 minutes to keep working out of that packet to finish those up. And like I said, tomorrow will be our Unit 2 test.